Today we are going to discuss on a basically blast furnace design and engineering section. Today we are looking at a critical section of the furnace known as Bosh. By definition, the Bosh is the section that narrow downward from the widest part of the furnace, the belly, down to hearth. Positionally, it sits directly above the tier where hot air is forcefully injected and below the belly. But why does it narrow? It primarily operational significance is to accommodate the massive reduction in material volume that happens as solid iron ore fuses and melt into liquid metal and slag. So why this specific angle of this narrowing so important? The primary design objective is structural support. The Bosch angle must support the cohesive or fusion zone, along with the immense weight of the descending solid layer above it. Beyond support, it dictates gas flow dynamics. By narrowing below the belly, the Bosch helps maintain the stability and position of melting zone directly above the tuer raceway. Finally, it facilitates material convergence, ensuring that descending coke and newly formed liquid flow smoothly into the hearth. Engineering this angle was not always a high-tech simulation. Over the last century, research led to three major empirical rules for determining the Bosch angle. First, the American 4 feet by 4 feet rule, prescribed as a very shallow 45-degree angle. Then British steel Scranthrop work developed the 12 feet by 5 feet rule, resulting in a 67.4-degree angle. Finally, Bethlehem Steel and European operators utilize the 21.5-degree rules, measuring from the vertical, which resulted in a 68.5-degree angle. This historical benchmark paved the way for the steeper design we see today. In modern blast furnaces design, we have moved towards much steeper profiles. Typical modern Bosch angle now ranges 70 degree and 85 degree. This trend is primarily driven by productivity. A steeper angle maximizes the furnace's internal working volume, allowing for more material processing. In terms of scaling, a typical Bosch height is approximately 0.45 times the throat dia. However, to minimize excessive wear, modern design rarely allow the Bosch height to exceed 3.5 meter. The critical impact on wear uh, is also very important. However, steeper is not always better. Research shows that the Bosch angle is a primary factor in longevity of furnace cooling system. If the angle is too high, greater than 75 degree, it can lead to an unstable fission zone position, causing excessive abrasion and premature failure of copper cooling staves. Conversely, shallower angle less than 75 degree provides better support for the fusion zone and have shown superior wear resistance. Furthermore, an improper boss to hearth transition can cause peripheral molten metal flow leading to dreaded elephant foot wear in the base of hearth wall. So we need to trade off productivity versus campaign life. Now, designing a blast furnace is an exercise in balance. On one hand, you have heavy productivity, steep angle increase, volume and output. On the other hand, you have a campaign life. Shallower angle protect the refractory and cooling elements, with the goal of reaching a 20-year lifespan without a major reline. There is a limit through. If angle is too low, under 70, the hearth volume becomes restricted, which eventually choke productivity. Designer must find the sweet spot that maximizes metal output while ensuring the furnace doesn't burn out prematurely. So, coming to wrap up part, the industry consensus supported by group like worldsteel suggests that maintaining a wash angle of less than 75 is the gold standard for stabilizing the fission zone and extending the stave life. As blast furnaces continue to grow in size, the challenge for the future is to design Bosch geometries that can handle higher gas velocity without sacrificing the structural integrity of the steel shell. So we can say that in the concluding an engineering consensus, this is the